Welcome to Chapter 7 on Geometrical Optics. In this chapter, we'll be studying the propagation of light. Okay. Optics is a study of light, and geometrical optics focus specifically on the propagation of light. So we'll be encountering things like reflection, refraction, in which light propagates and hits an interface or a change of medium. Okay. To study the propagation of light, we'll be using something called a ray model. Okay. We usually discuss light in terms of wave. Light behaves as wave actually when it's propagating through space. But to draw a diagram showing reflection, let's say this is reflection. If you draw the whole wave and show how it reflects, it can be a bit too complicated. The drawing can be a bit too complicated, yet the propagation cannot be shown clearly using this kind of drawing. So we devised simpler ways to show the propagation of wave by introducing the concept of wavefronts, where we just link up the dots of various waves that are in phase and we connect it with a line, and we call this line the wavefront. Okay, so all these are the peaks of the wave. In my case, I'm drawing the peaks of the wave as my wavefront. Okay, so I can see my wavefront coming in this way, after I get reflected that way. But wavefront is still not the simplest way of showing propagation. We are just focusing on the direction of propagation. So I believe knowing that it's going this way and that way is the more important thing, rather than the distance between wavefronts, the wavelength, the frequency. Those things are not our concern right now. So we can even simplify our diagram to be called a ray diagram. So for a ray diagram, we'll focus on just the direction of the wave traveling in space. In this case, the wave is coming this way, then it get reflected this way. We can simplify the drawing on wavefronts. We can just remove the wavefronts because we are not concerned with the characteristics of the wave itself. Okay, so this is called a ray diagram. So light, when it travels in an empty space, a vacuum, it will just travel in a straight line. There's nothing special about it, but something might happen if the light is encountering a change of medium. So let's say light is traveling in air and it encounters a glass, or it encounters a wall, or it encounters a liquid water, let's say. Okay, so this kind of situation, we call it a change of medium. And when the light is experiencing a change of medium where it travels, then you will experience either two kinds of phenomena. One we call it reflection, or we call it refraction. Okay, for our syllabus is these two kind of stuff. So for reflection, you follow the laws of reflection, which you learn from SPM. The first characteristic of reflection is the incident ray, the reflected ray, and the normal line should all be on the same plane. In this case, our plane is this paper itself, or your phone screen here will be the plane, and this plane contains these three lines all on the plane. You don't have something pointing out of page, you don't have something pointing to the page for this case. Okay, then the second characteristics for law of reflection is that the angle of incidence, which is the angle between the incident ray and the normal, will be equals to the angle of reflection, which is the angle between the normal line and the reflected ray. These two angles should be equal. So that's what you learn in your SPM. You just need to study, revise it, because it might be relevant for your study when it comes to spherical mirrors and lenses. Next, you learn about law of refraction. So law for refraction, what happens is if light is encountering a change of medium, just a reflection, refraction can occur also where the light gets transmitted through to another medium. But when light gets transmitted through to another medium, it might encounter a change in the direction of propagation. In this case, my drawing here is showing that the light is being directed towards normal. Okay, before that it's slightly away from normal. Now, due to the change of medium, it propagates slightly towards the normal. So this is a phenomenon which we call refraction. So the rays can be directed away from the normal or towards the normal. And how do we decide whether it's away or towards? We use the idea of Snell's law to determine the angle. Snell's law also depends on a concept which we call index of refraction, which actually depends on various mediums. Various mediums has various index of refraction, and different wavelength can have different index of refraction as well. So using this idea, we are able to determine how much should be the angle of refraction. So this sums up our revision on law of reflection and law of refraction.